Hello, folks. Let's walk through question number 2 on the calculator portion of the AP Calculus free response from 2017. As I'm reading the question, I will be underlining and circling some key information that we're going to use in parts A, B, C, and D. And I highly recommend that you do the same when you're taking the free response. When a certain grocery store opens, it has 50 pounds of bananas on the display table. Here, underline or circle 50 pounds of bananas because this is your initial amount. You want to do this so that later on you don't forget that this is here in the problem. Customers remove bananas from the display table at a rate modeled by f of t. Now next to f of t, I would put rate out because you're removing the bananas at this rate. And also keep an eye for the domain. T is greater than 0 but less than or equal to 12. Where f of t is measured in pounds per hour, here are your units. T is the number of hours after the store has been opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by G of t. Next to G of t, this is your rate in, and I would label it so that you don't forget it later. Again, keep an eye for the domain. Notice that here it is no longer from 0 to 12, but from 3 to 12, which this will play a role in part D of this problem, where again G of t is measured in pounds per hour, and t is the number of hours after the store has been opened. So part A, how many pounds of bananas are removed from the display table during the first 2 hours the store is open? How many in a net change problem should definitely signal an integral. Right? So you want to set up your integral right away anytime you're looking for the amount of something. Now, during the first 2 hours, you're going to start from t is equal to 0 up to 2. That is your time frame. And because you're removing bananas, you want to use the correct function, which represents the rate at which bananas are being removed. In this case, that is f of t. Close it off with dt. On the free response, you're going to have a ton of space to write when you really only need this simple setup. So it's a little bit deceiving, but trust that this is really all you have to write from 0 to 2. F of t, don't even copy the question. Don't even copy the function 10 plus 0.8t sine t cubed over 100, because if you make a mistake, then this is going to be counted against you. It's better to just simply write the name that is already given to the function. Now, I will do a separate video just on how to input this into the calculator. Then when you do so, you're going to find that the answer is 20.051. Always give your answers to 3 decimal places. And what I did here on the calculator is that I stored f of t into y1 so that it can later be used in the antiderivative without me having to retype everything again. And this is it, right? 20.051. The units for this problem, even though it is not being asked, it's always a good habit to develop to keep the units after the answer, and this is in pounds. So once you have 20.051 to 3 decimal places, move on to part B. And here goes. Part B says, find f prime of 7. Now, when you see a prime on this calculus test, or calculus AP exam, it should be a knee-jerk reaction. You're talking about rate of change. It is the derivative. We're going to have to derive f and evaluate the derivative at 7. Again, this is very easily done on the calculator. If you just go to Math 9 on the TI-84, sorry, Math 8 on the TI-84, and I have done so already. The answer here, when you derive f and evaluate it at 7, would be negative 8.119, but when you round it, it is 120, rounded to 3 decimal places. That's the easy part. Plug and chug into the calculator. Now, using correct units, explain what this actually means in the context of this problem. Before you get into, the rate of change is increasing, decreasing, address the 7 right away. You don't want to forget to mention it when you're writing out your response. Right away, put at time t is equal to 7 hours. Then you can worry about what f stands for and what f prime stands for. F in this case, of course, is the rate at which bananas are being removed. So start with that. The rate at which, and of course, look, you're not writing an essay. You don't have to make this fancy. The rate at which bananas are being removed. Now, because the answer is a negative 8.1119 or negative 8.120, the rates would be decreasing at this value, at 8.120. Now, using correct units, right? The units for this would be pounds per hour, but because this is the rate already for f of t, the change would be pounds per hour, which you can also write as pounds per hour squared. And this is all you really have to write for your answer. Moving on to letter C. Is the number of pounds of bananas on the display table increasing or decreasing as time t is equal to 5? And give a reason for your answer. Now, f of t and g of t are already functions that would give you the rate. If you think about it, the answer is pretty intuitive. If the rate at which you're adding bananas to this table, if that is higher than the rate at which you're removing the bananas, then the number of bananas on the table would be increasing. And also, same thing applies if the rate that you're adding bananas is less than the rate at which bananas are being removed, then the overall number of bananas on the display table would be decreasing. So for this problem, all you really have to do is find the rate at which bananas are being removed when t is equal to 5, and also the rate at which bananas are being added at t is equal to 5, and compare those two rates. See which rate is higher. Now, again, you can do this easily on the calculator. Here are my two answers. 13.796 pounds are being added per hour, and 11.533 pounds per hour of bananas are being this one is being removed, and this one is being added. And of course, we can see that the rate at which bananas are being removed is higher. Therefore, we can say the number of pounds of bananas is decreasing at time t is equal to 5 hours. And the reasoning is simple, because the removal rate, f of 5, is greater than the rate at which they're being added. And another way to write this would be f of 5, right, or the rate at which bananas are being removed, when you subtract that from the rate at which bananas are being added, if that gives you a negative number, this is also an indication that the number of bananas on the shelf is decreasing. And this is it. For moving on to letter D. How many pounds of bananas are on the display table at time t is equal to 8? So here again, we're looking for the amount of bananas, and we're given a time frame. And when you're looking for a final amount, you have to take into consideration three things: the initial amount plus the net change, or the rate in, minus the rate out. Right? This setup would always give you the final amount of something. Now, the something could be toilet paper, it could be oil, it could be water accumulating in a tank. The situations will be different, but the setup will always be pretty much the same. In this case, our initial amount, hopefully we circled it in the beginning, that is going to be 50 pounds of bananas, plus the rate in, that would be g of t. And be careful here, because the domain for g of t doesn't start at 0. The time frame starts not from 0, but from 3 to 12. And the rate at which bananas are being removed starts from 0 to 12. So this is the one little tricky part about part D. The rest is all plugging it into the calculator, making sure that you put the functions into the right order. And once that's done, once you plug it into your trusty calculator, you're going to get 23.347 as your final answers. And again, because you're talking about how many pounds of bananas, the units here would be pounds. And that is all, folks, for question number 2.